This is Connie Renee for our PowerPoint on understanding number concepts. First, how children learn number concepts. By counting objects, knowing one more, one less, counting objects by groups, and using symbols. So counting objects, students are able to do one-to-one correspondence. They keep track of an unorganized pile. They notice when recounting a group results in a different number. They spontaneously check by recounting to see if the result is the same, and they know how many after counting. Spontaneously adjust to our estimates while counting and makes a closer estimate. Knowing one more, one less. The student knows one more or one less in sequence without counting. Notices if a counting pattern doesn't make sense. Knows one more or one less without counting when numbers are out of sequence. Counting objects by group. The student can count by groups by moving the appropriate group of counters, and they know that quantity stays the same when counted by different size groups. Next, using symbols. They use numerals or numbers to describe the quantities they see. High-quality activities and how to choose them. The teacher should provide opportunities for children to explain their thinking as they interact with mathematics in deep and sustained ways. Build on children's experience and knowledge, taking advantage of some familiar text, so things that they are familiar with. Enhance students' natural interest in mathematics and their instinct to use it to make sense of their world. And the teachers base mathematics curriculum and teaching practices, solid understanding of both mathematics and child development. And that will equal a successful outcome. The ability to subitize. So some of these activities would be an instant recognition activity, and that would be dot plates. And they're exciting. They can be done in 5 minutes at any time of day and any time of year. So it's just reviewing what they know or maybe what they have not learned yet, and repeating that so they will learn it quicker. An example would be to use this website as a class, and that kind of just shows you an activity of students doing that, subitizing. It shows that students use patterns and ask them to choose the correct quantity. Early counting. Each number is more than the previous number. So an example would be to show a card with five large dots. Ask the student to count the dots. Then student how many dots are on the card. Then ask the student to get the same number of counters as there are dots on the card. Numeral writing and recognition. An example would be to have students trace the numbers in shaving cream on their desk, form the number with clay, or maybe write the numbers in the air. Counting on and counting back. Frequent short practice sessions are recommended. An example would be to have 5 students stand up, as a whole class count them, they say a number, have the students sit down. Then count backwards. Have the last student that sat stand and say 5. So it would be 1, 2, 3, 4, 5, and then going backwards 5, 4, 3, 2, 1. More than, less than, and equal to. An example would be at a workstation provide about 8 cards with pictures of sets of 4 to 12 objects. A set of counters, word cards, that are labeled more, less, and same. Paper plate, below boxes to support students that have disabilities or physical needs. Next to each card, have students make 3 collections of counters. A set that is more than the amount on the card, one that is less, and one that is the same. Start students with disabilities maybe just matching the set that is the same. Next, early number sense. It develops gradually as a result of exploring numbers, visualizing them in a variety of contexts, and relating them in ways that are not limited by traditional algorithms. Next is relationships between numbers 1 through 10. 1 and 2 more, 1 and 2 less. So an example would be the numbers 6, 7, and 9. So 1 more than 6 would be 7, 2 more would be 9. And then going back is 9 was the number, 2 less would be 7, 1 less would be 6. and then providing anchor 5 and 10 with part whole activities. So to review, being successful with number concepts are inclusion, all objects previously counted, one-to-one correspondence, one word for each object we count, conservation of number, so the number of objects does not change when the objects are moved, rearranged, or hidden, so it stays the same. Number sense and relationships. Count for a purpose. Relate between numbers, build visual images of quantities.
Understanding addition and subtraction is understanding content connections, such as number, basic facts, place value, computation, algebraic thinking, and fraction and decimal computation. For the means of this chapter, we are only going to go through a few parts, and the first one is parts of numbers, understanding the compositions and decompositions of numbers. That is taking away and putting together numbers, say 2 plus 3 equals 5, 5 minus 3 equals 2. It's having the same components, being able to deconstruct or put them back together. Memorizing equations. Children do not usually see basic facts are related to each other if they're just memorizing equations. They cannot work on the equations they have not memorized. So this is being able to teach children basic facts, understanding the meaning of operations, confirm with addition and subtraction, so that subtraction facts are a natural consequence of having learned addition. A firm connection between multiplication and division provides a similar benefit. So you cannot just memorize equations. Some basic math facts, such as the doubles, are good to memorize because then you can add and subtract. But if your child hasn't seen a certain problem before, they should be able to use strategies to work that out. And this comes up to knowing the parts of numbers through 10. The relationships or parts of the number. So composed as parts of 8 plus 2 equals 7 plus 3 equals 9 plus 1. Those connections. Knowing how to read and write symbols are synonymous with understanding the number concepts represented by these symbols. So what does a plus mean? What does a minus mean? How is equals related? And working with symbols is really important. That's why it's a reoccurring concept. Numerals should be taught in association with the quantities they represent. Seeing the symbols should trigger visualization and have meaning as labels for quantities. It is so important to support student learning. By experiencing the relationship between the number and the symbol, they can be achieved through counting, comparing, composing and decomposing actual groups of objects. For example, 3 apples and 4 apples equals 7 apples. What is the connection between the number and the symbol? Talking to children about when you add 4 apples to the original 3, which is the addition or the joining number, the relationship between the object and the symbol, addition, means that there are 7 apples. How does this work? That comes into the composing and decomposing and will be illustrated in the next slide to our critical learning processes. The critical learning phases are combining parts of a number, decomposing numbers. The critical learning phases are combining parts of a number, decomposing numbers, using symbols and identifying parts of numbers. Each of these will be described and an example will be added at the end to illustrate each of these components. The critical learning phases are combining parts. Identifying parts of a number is one of the main components of critical learning phases. It includes chunk numbers, which is recognizing that one number is contained in another number, that 1 apple is part of the group of 3, that recognizing groups of numbers to 5 in a variety of configurations, 4 plus 1, 3 plus 2, and learning that parts of a number leads taking the numbers apart and putting them back together. These 2 key components is decomposing numbers and identifying parts of a number. Decomposing number, as the illustration shows, is combining and breaking apart numbers. It identifies missing parts by using related combinations and knowing missing parts of numbers to 10. This shows an example of composing to combine numbers up to 5. How 3 and 2, 2 and 3, and 1 and 4 compose to make 5, the number 5, and how you decompose it to break it apart. In talking about parts of the number, it describes parts of the numbers, counts on to determine total, and knowing that the amount is not changed when the number is broken apart and recombined in various ways. Combining parts by using related combinations. Again, this is illustrated in the picture below, showing that 4 plus 2 plus 6 is still going to become the total of 12. Another area below is that they're asking for 6 plus 6 equals 12. So combining 4 plus 2, breaking apart these two numbers, showing that they can be different components but will equal the same amount. Using symbols is a recurring concept throughout this chapter of number concepts and operations, because recognizing a symbol without knowing the concept it represents is virtually useless. Therefore, numerals should not be taught in isolation but always in association with the quantities they represent. Seeing the symbols should trigger the visual image of what they stand for. Numerical symbols, they need to have a meaning, and only when they're introduced as labels for quantities. Developing meanings for the operation. The key concept for this chapter is meanings, interpretations, and relationships of the 4 operations: addition, subtraction, multiplication, and division, and how they connect to make operation sense. Operation sense is accurately and fluently applying these operations in real-world setting, day life. The 4 big ideas within information, concepts, and meaning is that addition and subtraction are connected. Addition names the whole in terms of the parts, and subtraction names the missing part. This is talked about later on with examples to show the quantity unknown, and that is usually result, change, or start within the joining problems and the separate problems. Multiplication involves counting groups of equal size and determining how many are in all. Multiplication and division are related. Division names a missing factor in terms of the known factor and the product. And models can be used to solve contextual problems for all operations and to figure out what operation is involved in a problem. These will be shown through examples of arrays, number lines, and equals x. The first big idea is addition and subtraction are connected. Addition names the whole in terms of the parts, and subtraction names the missing part. What's important about this is that joining and separate classifications are involved in 3 quantities: a start amount, a change amount, the part being added or joined, or separated, and the resulting amount, the total amount after the change takes place. The separate classification is the start amount is the whole or the largest amount, which is that an amount is being removed or taken away from the start value. Result unknown is the change unknown and the start unknown. There are 2 types of problems within the realm of addition and subtraction. These are part-part whole problems, which involve 2 parts that are combined into one whole. Either the missing whole or one of the missing parts unknown must be found. That is, again, relating back to the start amount, the change amount, and the resulting. And the comparing problems, which involves the comparison of 2 quantities. The third amount does not actually exist, but it's the difference between the 2 amounts. There is the difference unknown, the larger unknown, and the smaller unknown. Join and separation classification are important meanings for the learner to know. It is backed up by basic facts and computation. Basic facts is understanding